Hello students, here is another example for the binomial probability distribution. A manufacturing machine has a 1% defect rate. If 10 items are chosen at random, what is the probability that at least one will have a defect? So in this question, this is a binomial distribution, and so we need to determine two numbers. N, which is the number of trials, that is 10 items chosen, and P is the probability of success, which is choosing a defect item here, which is 1%, so this is 0.01, translating from 1%. Again, you can use Excel in order to convert percentages into numbers. So if I want to convert 1% into a number, I will just go to the number and then click the home button, and then go to the number section and then select this to turn it into a decimal. Please remember always to turn any percentage into decimal number before you start working with it. Now, the second step in order to answer that question is to build a table. I like to keep it systematic, so you're not going to make a lot of mistakes. So at least if you get the table right, you're going to get partial credit for your answer. So here I have 0 to 10. I usually just type the first three numbers and then select them and then go to the edges as I am going to populate, and then drag it down until I get 10 numbers or whatever numbers I have. Just because here we have the number of trials 10, I know that I have to start from 0 to 10. One mistake that students do is not starting from 0. 0 is a possibility. 0 is selecting no items that are defect. In this case, in this specific context. Now I'm going to compute the binomial distribution for each of these cases. I'm going to start with 0 by clicking on 0. The number of trials is 10. The probability of success here, which is selecting a defect item, is 0.01 or 1%. And then I'm going to choose false because that is the case for the binomial distribution. I have no interest in accumulating all of these probabilities. Now, the question says, what is the probability at least one will have a defect? At least one will have a defect. That means either 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10 will have defect. So I'm going to add all of these items or all of these probabilities. So I'm going to add all of these probabilities. Leave out the probability of 0, which is the highest. Okay, now that will be my answer. I just have to copy and paste it into the place, and I'm done with that specific question. Here's another example. A baseball player has a batting average of 0.265. What is the probability that he has exactly 3 hits in his next 7 at-bats? So it's very important in these types of questions to determine N and P. In this case, N is equal to 7 because that is how many chances this player has at bats, and then the probability of success, which is getting the hit, is 0.265. So I'm going to build another table based on this information. I will have X and I will have P of X, the probability. So I have 0 to 7, and then the probability is going to be binomial dot distribution of the number, comma, the number of trials is 7, comma, the probability 0.267. I believe that is the case, 65, and then comma, false. And now I'm going to populate. The question says, what is the probability that exactly 3, the player gets exactly 3 hits? So exactly 3 hits is the number in front of 3, which is this number. So I just copy this number and paste it into my homework set. I hope this video helped you understand how to solve questions from the binomial probability distribution, and I will see you in a different video.